Hey, Miss Marion here. Let's go ahead and go through lesson 5 of chapter 4. So make sure you have your workbook with you, and let's go ahead and go through this. All right, jump start. Page 47. Determine which of the inequalities matches each phrase. You are going to need to know this for today. So make sure you go through it, put the answers on there, and then come back to me. All right, here are the answers as far as the different things. So no more than, so less than or equal to. More than, so greater than, right? At least, that is 7 or above, so it's greater than or equal to. Cannot exceed, so it has to be less than or equal to. A minimum of, so that means you can be 7 or more, so minimum of age of 16 you have to drive, right? No less than, so that means it has to be greater than or equal to. A maximum of, so it can only go up to it, so that is x is less than or equal to 7. And then fewer than is x is less than 7. So make sure you understand these, because write them down. You might have to come back to them and fix some different things. All right, so this is our objectives to today. So I can write and solve the inequalities to model real world situations. And so we need to keep in mind, how can inequalities be used to find solutions to real problem situations? So this is our goal. This is what we're going to be able to do for today. And that's what we're going to be covering for today. All right, on page 48 in the logic area, we're going to talk about Elvira again. It says Elvira, the cafeteria manager, needs to be careful with her spending, and she manages the cafeteria budget so that they can serve the best food at the lowest cost. To do this, Elvira keeps good records and analysis of all of her budgets. So number 1, Elvira's, okay, and we'll read it without the numbers first. So Elvira's cafeteria has those cute little cartons of milk that are typical of school lunch. The milk suppliers charge blank per carton of milk, in addition to a delivery charge of blank. What is the maximum number of milk cartons that Elvira can buy if she has blank budgeted for milk? So think about that and then come back. All right, so now let's go ahead and read it with the numbers. So Elvira's cafeteria has those cute little cartons of milk that are typical of school lunch. The milk supplier charges 35 cents per carton of milk, in addition to a delivery charge of $75. What is the maximum number of milk cartons that Elvira can buy if she has a budget of $500 for milk? So don't jump the gun yet. We're going to be doing some stuff, okay? But kind of think about that, and we're going to be writing an equation that goes along with this. All right, so the questions that we're asked to do is write and solve an inequality that models this situation, describe in words the quantities that would work in this situation, and then write your answer using appropriate notation. So we're going to go ahead and kind of go through this. There's a couple of things that are going to be a little bit new, so make sure that you kind of follow along. So let's go ahead, let's make an equation. I'm going to notate mathematically the information is given to us. So I have a maximum budget of $500. I know that there's 35 cents per carton. I need to know the maximum number of milk cartons. And also there's $75 charge. So I'm going to say let X equal number of cartons of milk. Okay, and I'm going to move this up so we can write an equation. So I know that $500, and I kind of do this backwards, so I do apologize on this. But I know $500 is the max. So that means I can spend kind of like less than or equal to in a way, this way. I know that I'm going to spend $75 no matter what. And then I don't know how many cartons there are, but I do know that there's 35 cents per carton. So this is the equation that goes along with this story. So let's go ahead and solve this. So we're going to go ahead. Oh, what's our first step? Let's get rid of the 75. All right, grab your calculators. Let's go ahead and figure this out. So 500 divided 75, that's 425. Less than or equal to 0.35x. We want to get x by himself. 35 cents and x, they are multiplying. So we are going to divide by 35 cents. All right, and then we're going to have X is less than or equal to $1,214. And notice how we have this decimal. So we're trying to find numbers of cartons of milk. So we can we have 0.28 carton of the milk? No, right? And so that means I need to go ahead and round this. But do I have enough money for $1,215? I don't. So that means I'm going to round it to 1,214. So this is the number of cartons I can have. So this was pretty much A. Now let's go ahead and let's talk about B. B says, describing words with the quantities that you can work in this situation. So we're going to say Elvira can buy no more than 1,214 cartons. Oops, 1010, not 2. Cartons of milk. Okay, so now let's kind of think about this. We're going to write our names, we're going to write our answer using appropriate notation. So think about it as far as, this is what is called interval notation. Now, can she buy negative cartons? Think about it. Can we buy negative cartons? No, we can't. So what we're going to do is we're going to put this bracket, 0, comma, and then 1,214 with a bracket on it. So if we have brackets this way, it says it includes that number. So that means she could buy 0 cartons of milk, but then she's going to go all the way up to 1,214 cartons of milk. This is what is called interval notation. Make sure you write this down because we're going to need to know this. The other thing that we need to talk about is what is called set notation. Set notation is we're going to have curly brackets. We're going to have C. Actually, we're going to put X in there. So, because that is our variable. So we have our variable, then we have this up and down. So it says our X is in the form of, and we go from 0 less than or equal to X less than or equal to 1,214. And then we're going to finish off with this curly Q. So there's 2 different ways of actually writing this. There are 2 correct mathematical ways of writing it, where this is interval notation where it has the brackets. This is set notation where it has a curly. And then the set notation, it has more information. It's, hey, we solved for X. And then these are the boundaries it can be in. It goes from 0 all the way up to 1,214. Write this in your book. You are going to need to know this. So make sure you have it. So I'm going to pause for a second, and then we're going to go on to the next one. All right, so number 2, students love to put ranch dressing on everything, so Elvira needs to keep plenty in stock. The students eat about 2.25 gallons of ranch each day, so I'm going to underline that. Elvira started the school year with 130 gallons of ranch. She needs to have at least 20 gallons left when she records to have enough in stock until she needs to reorder. And so we are looking for how many days will her ranch dressing supply last before she needs to reorder. So first of all, let's start with A. Write and solve an inequality that models this situation. So go ahead and do that and then come back to me. All right, so I'm going to move this up so I have more room. And we're going to say A, we need to define our variable. So we're talking about ranch. Let's do R. R equals, and then, oh, actually it's not ranch. We're actually trying to find, what are we trying to find? Oh, number of days. So let's do D is number of days until she reorders. All right, so she needs 20, so she can't go less than 20. So everything that we're going to do is going to be bigger or greater than or equal to. She starts with the 130. She's taking off 2.25 gallons of ranch each day. We don't know how many days, so then this will be our equation. Okay, now let's go ahead and solve it. So go ahead and solve, and then come back to me. All right, so we're going to subtract by 130 both sides. So we have negative 2.25D greater than or equal to, and then we have 20 minus 130, negative 110. Ooh, we have this negative stuff. Huh, that's kind of weird. 225, negative 225 is multiplying, so we're going to divide by negative 2.25. Divide, negative 2.25. Still trying to solve for D. So I have D, and then negative 110 divided by negative 2.25 is negative 48.8 repeated, right? But what is that really can? Oh, I multiplied or divide by a negative on both sides of the equation. So what do I need to go ahead and do? I need to go ahead and flip that sign. So we have D is less than or equal to 48. Sorry, that should be positive. 0.8 repeated. So then in B, we need to go ahead and write an equation, right? Elvira. Well, So can we have 0.8 of a day? Not really. So we need to round down and make it just 48, right? So let's go ahead and let's put this into a sentence. Elvira needs to reorder after 48 days. So no matter what, at the 48 days, she can reorder, but she can actually order at any time. Pretty much, she can actually order from 0 to 48 days. Oh, let's put that in there. So Elvira can reorder or needs to reorder ranch dressing, because that's what we're looking, between 0 and 48 days. Okay, now go ahead and put that into interval notation and set notation. So remember, interval notation is the brackets. All right. And then we have set notation. Curly bracket. What are we trying to solve for? Our variable. So we have D, this line. So it says D is set as between 0 less than or equal to D less than or equal to 48. Awesome. All right, let's try number 3. It says the price on many of the cafeteria foods changed during the year. Elvira finds that she orders veggie burgers 4 times and paid $78, $72, $87, and $90 on the orders. To stay with her budget, Elvira needs to be sure that she finds the average order that is no more than $82. How much can she spend on the 5th order? Okay, write an equation and then go ahead and solve it. All right, let's write our equation. We need to define our variable. So we're going to say this is AX equal the amount of the average of 5 orders. Okay, so let's go ahead and write an equation itself. So we have it where it's an average. So we have 78, 72, 87, 90, and then we have this average of the extra 5th order, and then we're going to divide that all by 5, and then all of this has to be less than or equal to $82 because she doesn't want to spend more than that. So this is our equation. So let's add all of these numbers together to make it easier. So let's go ahead and let's do 78 plus 72 plus 87 plus 90. That is 327 plus x divided by 5 less than or equal to 82. If you wanted to start with getting rid of the 5 at first, that's fine. I just like to kind of combine them together. From here, I'm going to go ahead, I'm going to multiply by 5 on both sides. Because we're divide, opposite of multiply. 327 plus x less or equal to, so we have 82 times 5 is 410. So we're going to go ahead, we're going to subtract off 327. So now we're going to have x is less than or equal to 83. So as long as the order is less than $83, the average of the 5 orders will be less than 82. So as long as, so we're going to put this into a sentence. As long as the order, so the 5th order is less than $83, then the average of 5 orders will be $82. Okay, and then again, we need to go ahead and we need to put this into different notations. I'm going to pause and let you do that right now and then come back to me. So interval notation. Again, that's the one with the brackets. Starts at 0, we'll go up to 83. And then set notation. So right now we're writing these as if she doesn't have any refunds or anything like that. This is the bracket, variable, set as 0, less than x, less than or equal to 83, closure bracket. Awesome. All right, number 4, Elvira can purchase ready-made pizzas for $14.50 each. If she makes them in the cafeteria, she can spend $44.20 on ingredient and $6.25 per pizza on labor. For how many pizzas is it cheaper for the cafeteria to make the pizzas themselves rather than buy them ready-made? So kind of think about this one, write an equation, and then come back to me. So we have ready-made is $14.50. I'm going to change my highlighter. She can spend $44.20 and then $6 per labor. And how many pizzas? Okay. So let's kind of think about this. We have, this equation is going to be different. So we're going to put P equal the number of pizzas pretty much that she can make, right? So I can either do $14.50 per pizza, right? And then we want to figure out that when pretty much it's less than, like how to make one is less than the $14.50 per pizza. So we have $14.50 per pizza. That is the store-bought. And then to make one, she spends $44.20 per pizza, but then also $6.25 per labor. So she does the $44.20 at first, buy the ingredients, $6.25 per pizza on the labor. We don't know how many pizzas is that she's going to buy. So this is actually our equation. So starting with our variable, dividing our variable, and then here's our equation. Go ahead and solve it and then come back to me. All right, so I want all the variables on one side. Oh, I am so sorry. I'm sure you're like, Miss Marion, you made a mistake. This should be P. All right, so I want all the P's at the same side. So sorry about that. We're going to subtract off 625. All right, so grab 1450 minus 625. We're going to have 825 per pizza, 44.20 left over. And then we're going to divide by 825. So pizzas is greater than 5.35. Okay, so let's think about it. Oh, I'm going to move this up so we can look at it. So let's think about this. I need my variable. So P is the number of pizzas. So Elvira will need to make 6 pizzas, right? Because can you have 0.35 of a pizza? No. We do need to round this up because we're talking about like how many pizzas it would take to make it cheaper. So we're going to round it up to 6. And then we're going to explain it. So Elvira so 6 or more pizzas would make it cheaper in the cafeteria. So we'll do it that way. 6 or more pizzas. Well, we can say that Elvira will need to make 6 or more pizzas to be cheaper. APR in the cafeteria. All right, so now you need to do set notation for me. So go ahead and do that and then come back to me. All right, so interval notation. So we are starting, so she'll need to make 6 or more pizzas. So that means we need to start with 6, and then she can go as many as she wants. So we can go all the way up to infinity. Notice how I now put this kind of the parentheses instead of the bracket. The bracket says we're going to include this number. The parentheses pretty much we're not going to include it, but infinity goes on forever. So this parenthesis actually goes with the infinity number, and to kind of like it's something that we're including, like in a way not including. And then set notation. So that was the interval notation. We need our set notation. Again, it is our curly bracket. We have P. P is defined as, well, it's going to be great. P is greater than 6. And then close that set notation because we're not confined right between like 0 and 6. That means she has to do 6 or more. That's how we do this set notation for this situation. All right, moving on, page 50, we're looking at number 5. So Elvira is comparing prices between 2 different suppliers of fresh lettuce. Val's Veggies charges $250 for delivery plus $1.50 per bag of lettuce. Sally charges $100 for delivery plus $4 per bag for lettuce. How many bags of lettuce must be purchased for Val's Veggies to be cheaper option? So think about that on how you're going to set it up. But we do know we're looking for bags of lettuce. So go ahead and do that and then come back to me. Okay, so we're talking about the 2. We want Val's to be to make the cheaper option, right? So Val's has to deal with $2.50, $1.50 per bag. Oh, sorry, we have to define a variable. So we're going to say P, I'm going to do B, bags of lettuce. Use any variable you want, okay? So Val is going to be looking for the cheaper side. So we're going to do $2.50, that's the flat fee, plus $1.50 per bag. And then we're using Sally's as the other kind of stuff. And Sally's is 100 and then $4 per bag. So she starts at 100 and then $4 per bag. So this is the equation because we're going to be comparing the two. This is the equation that goes along with the situation. Okay, now solve it and then come back to me. All right, so I like to have, well, it doesn't really matter, but let's go ahead and subtract off the $1.50 B. So we have $2.50. Oops, yep. Less or equal to, we still have our 100. Then we have our 4 minus $1.50. So that's $2.50 per bag. And then I need to go ahead, I need to put variables one side, numbers on the other. So then I have $2.50 minus 100, so I have $1.50 less or equal to $2.50 per bag. That means I need to divide by the $2.50. Right, and then I have B is going to, so 150 divided by 250, 60. Okay, this is great, but now we have to explain it. Remember, we always want to have our variable on one side and our numbers on the other when we're dealing with inequalities. It is easier to read it. So I'm going to put B on the left-hand side, 60 on the others, and then notice how this is pointing towards the 60. I'm going to make it so it's pointing toward the 60. So I took this whole entire thing and I flopped it. Why did I want it this way? Because I can actually look at that B. It says B is greater than 60. Well, that means Elvira needs to buy 60 or more bags to make Val's veggies cheaper. Let's write that down. So Elvira needs to buy 60 or more. More bags of lettuce to have Val's veggies be the cheapest. Okay, now go ahead and put this in set notation. So interval notation and set notation. Go ahead and do the notations for it. So interval notation, right? That's the brackets. So she needs to have 60 or more. So that means you're going to start with 60 and buy as many as you want. So going on to infinity. Remember, infinity has the parentheses instead of the bracket. And then set notation, right? And we are going to, it's the curlies, B. So B is being defined as B is greater than 60. And then close that bracket. All right, number 6 says each student who buys a school lunch pays $2.75. The cafeteria typically brings in $1,168.75. Or between those two each day. So 1,438.25. How many students does the cafeteria usually serve each day? So kind of think about this and then come back to me. So this one's different. It's really different, and it's actually quite new. So let's go ahead. First of all, let's define a variable. So this is A. So we're going to say A equals number of students Okay, so we're going to put X in the middle. number of students. And we know that those number of students, how much do they pay per lunch? That's $2.75. So it's $2.75 per student. And the big number is the 1,438.25. Bottom number is 1,168.75. This is the range. And technically it's actually two equations. So if you look at it, it is the bottom equation. So pretty much the bottom amount, a number that they have is the 1,168.75, and it's $2.75 per person. And then notice how we have another equation of $2.75 per person, and it cannot be bigger than the 1,348.25. So technically they're solving two equations at once. So they're trying to find the low amount, what makes the low amount, and then what makes that higher amount. So go ahead and solve both of these, and then we'll talk about how to put this in answer form. All right, let's go ahead and solve this. So we are going to divide by 275 on both sides. 1,168.75 divided by 275. We get 425 less than x. So again, we want the variable on the left-hand side. So we're going to say x is less than 425. And then let's solve the other one. Again, we're going to divide by 275 on both sides. So we're going to have x is going to equal, so 1438.25 divided by 275, 523. So notice how we have like these two things. So the lower number is 425. The higher number is 525. So let's go ahead, let's put this into a sentence because that's letter B, right? And what it is that on a typical day, between 425 and 523 students are served. Right? That's the range that they normally sell lunches. So now let's go ahead and let's put this into notation form. So interval notation. So what's that lower number? It's going to be the 425. And these are actually, so because we have it where it's x is less than, not x and or equal to, these numbers are not equal to it. So are we going to do, the brackets? No, we're going to do the parentheses, meaning that we're not going all the way to 425. We're actually going really close to 425. So we're actually going to 426. And then we're going all the way up to 523. But again, notice how it's x is less than, not equal to. Then we're going to put this parenthesis kind of stuff. So brackets is equal to, parentheses is not. So this is the interval notation. So then we're going to go ahead and we're going to write down our set notation. So we have our curly bracket. We are talking about x, the number of students. It is defined as, and then we're going to go from 425 to 523. And notice how it is, the 425 is the bottom part, not equal to, and then we go up to 523, but not equal to. So this is how we kind of do two things in once, because they wanted the lower end, but they also wanted the higher end, because we were giving the 1,168.75 amount of money, and then the higher end was 1,438.25 amount of money, and it's going to go in between those two. So if you're not understanding it, go back, rewind, and then come back, okay? All right, so we did a lot of stuff today, And go ahead and make sure that you have all this written down. Or say, what are some takeaways as far as inequalities? Well, we can add or subtract terms from both sides of the equation, like equations. We need to reverse the inequality when we multiply or divide by a negative number on both sides of the equation. I'm going to add on both sides of the equation. On both sides of the equation. That's what we did in 8th grade. And then we're going to interpret the solutions for the context. That's what we were doing. Compound inequalities, those are the ones that go together. That was that last one. So an inequality that combines two inequalities, either so that a solution must meet both conscious, or the solution must conditions. So it's kind of where we were looking at that bottom amount and that top amount. So these are what are called compound inequalities. So make sure you have this written down on page 51 is where we are. So make sure this is written down. All right, so this is in our retrieval. This is part of our homework. It is on page 52. So we want to go ahead and we want to graph both of these equations. So the first one, our slope is -5 or -5/1. Our y-intercept is 3. So let's go ahead, let's put our x and y axis on here. So we're going to go up to 3, put a point. We're going to draw the -5/1. So down 5, 1, 2, 3, 4, 5/1. And I like to do it one more time. 1, 2, 3, 4, 5/1. And connect them together. All right. Lower one, it's in blue. So our slope is 3 or 3/1. Y-intercept is -5. So I'm going to start at -5. 1, 2, 3, 4, 5. Right? And then we're going to go up 3/1, up 3/1. And where do they cross? They cross at 1, -2. All right, so make sure you go ahead and do the practice problems. Go ahead and get into Canvas, put those answers in there, and we'll go from there. Have a good day. Thanks. Bye.